Statistical tests begin with a claim about a population parameter. This claim is called a hypothesis, and it allows us to formalize a question we want to answer using data. For example, we might ask whether a new strategy increases sales, whether a process meets a standard, or whether two groups differ. Hypothesis testing gives us a structured way to answer these questions using sample data. Hypotheses always come in pairs. We have the null hypothesis denoted H0 and the alternative hypothesis denoted HA. These two statements work together to frame the statistical question we are trying to answer. The null hypothesis represents the default or baseline assumption. It usually states that there is no effect, no difference, or no change in the population. For example, we might have mu equals 0, p equals 0.5, or mu 1 minus mu 2 equals 0. The alternative hypothesis represents what we are trying to find evidence for. It suggests that there is an effect, a difference, or a change. In practice, the alternative hypothesis reflects the research question or the practical concern we care about. The logic of hypothesis testing begins by assuming that the null hypothesis is true. We then use sample data to evaluate whether this assumption is reasonable. If the observed data would be very unlikely under the null hypothesis, we reject it. Otherwise, we fail to reject it. It is important to remember that our conclusions are probabilistic, not certain. We are not proving anything with absolute certainty. Instead, we are evaluating how plausible the null hypothesis is given the observed data. A helpful way to understand hypothesis testing is through a legal analogy. The null hypothesis is like the presumption of innocence. The alternative hypothesis is like guilt, and the data serve as the evidence in a trial. In a trial, we do not prove innocence. We either have enough evidence to convict or we do not. Similarly, in statistics, we never accept the null hypothesis. We either reject it or fail to reject it. Failing to reject the null does not mean it is true. It simply means we did not have enough evidence. A parameter is a numerical value that describes a population, such as mu, p, or the difference between two means. A statistic, on the other hand, is computed from a sample, such as x bar or p hat. A key rule is that hypotheses are always written about parameters, not statistics. We never write hypotheses using sample quantities like x bar or p hat. The null hypothesis usually takes the form parameter equals some value. This value typically represents no effect, no difference, or some benchmark we are comparing against. The alternative hypothesis can take several forms. In a two-sided test, we write h sub a. The parameter is not equal to some value, which means that any difference from the null value matters. In a right-tailed test, we write h sub a. The parameter is greater than some value, which focuses on detecting increases. In a left-tailed test, we write h sub a. The parameter is less than some value, which focuses on detecting decreases. The choice of alternative hypothesis depends on the research question. We must decide whether any difference matters or whether we are specifically interested in increases or decreases. Consider a study of a new cholesterol-lowering drug, and let mu represent the mean reduction in LDL cholesterol. Hypotheses are h sub 0, mu is equal to 0, and h sub a, mu is greater than 0. This is a one-sided test because we are only interested in whether the drug reduces cholesterol. In another example, a geneticist compares gene expression between treated and control groups. Let mu sub t and mu sub c represent the mean expression levels. The hypotheses are h sub 0, mu sub t minus mu sub c is equal to 0, and h sub a, mu sub t minus mu sub c not equal to 0. This is a two-sided test because any difference matters. Finally, consider a coffee manufacturer that labels packages as 500 grams. If customers suspect underfilling, we define mu as the true mean weight and test mu equal to 500 versus mu less than 500. This is a left-tailed test focused on detecting whether the mean is below the labeled value. In summary, hypothesis testing compares a null hypothesis of no change against an alternative hypothesis of some change. We always write hypotheses about parameters, and our decision is either to reject the null hypothesis or fail to reject it. A final important point is that a hypothesis test never proves the alternative hypothesis. It only provides evidence against the null hypothesis. This perspective is essential for correctly interpreting the results of any statistical test.